Hey, Wiz. So it's 2025. You've heard about agents, right? You've heard about these things?
Yeah, I think we're in like the year of them.
Yeah. Like it's like the thing this year. Like, but what are they exactly?
That feels like a really simple, really easy question to
Yeah.
answer, I think. Yeah.
Yeah. I know. Somehow nobody agrees on exactly what they are, though. And I think it makes it a little bit tough for people getting into the field for the first time, right? It's like, what am I supposed to do with this idea of an agent? I want it, I want to build it, but I don't know exactly what it is, and I don't know exactly what my boss is asking me for. So, what's the easiest way for the builder today who's just getting started to think about agents? Let's start there.
Yeah. It's almost impossible to answer, right? Like we're gonna do our best today to walk through what it means right now in the context of right now, right?
Mm,
But we the year is still young,
it
right?
is.
There's still more to uncover. We're finally starting to see a little bit through the mist, right? We got some
Mm,
fogged glass instead of a slate, object in front of us, but
that's right.
it's a little hazy still.
Okay, so we're getting more definitions along the way. We've seen this before in the industry at the edge here, where we have a word and we keep working with it, and then we have to go deeper and deeper and deeper and come up with new words to help define actually that amorphous, ephemeral word. Agent is sort of in this space right now, and today is all about going through the many definitions from the original OG textbook on AI all the way up to what OpenAI put out just this month, to what people have a problem with OpenAI saying about agents, to the future of what an agentic world might look like in AI driven organizations that have many employees that are actually robots with agency. So like it gets pretty wild here in the 21st century. We're going to try to outline all of this today. Also, you're going to walk through, for the builders here, 8 different agent frameworks. You're going to sort of show how the code looks for a simple agent in each one, and we'll define agent for 8 different frameworks today. At the very end, that's the demo. That's going to be a banger demo. I mean, I'm excited for this.
You're gonna see very quickly that everyone does things the same, but a little bit different. Yeah.
You know what? And I think that's the story of agents today. It's something like that. Um, Well, I think without further ado, we should go ahead and start defining things. We've got lots of discussions along the way. The Wiz can't answer it simply. It must be a generally complicated topic. I'm really, really excited to dive into this today. This will be a fun one, Wiz. See you back for the first discussion. All right, everybody, welcome to What is an Agent? I'm really excited for this discussion today. This is something we thought deeply about for years, and it's something that continues to be refined out here at the edge. Thank you for joining us live. If you have questions along the way, please throw them into the Slido link on your viewing platform. It's in the description box, or just jump in while we're having a discussion here on YouTube Live, and we might go ahead and just answer your question. A lot of great concepts to try to dive into today. We'll give you the code as we always do, but it will be a whirlwind at the end. So tune in for that as well. Let's go ahead and kick it off here. Like, really, what is an agent in 2025? That is the question, and we must find an answer. So today we want to try to figure this out. We want to kind of align ourselves to looking at definitions, looking at opinions, looking at what experts say, looking at what we've learned along the way, teaching this kind of material over the past, really 2 years, but, rooted in many years of teaching, 4 or 5 years of teaching these boot camps out at the edge in machine learning engineering, which kind of dovetailed into AI engineering. How's all this lead into where we sort of see ourselves today? Like, how does this connect to things like MCP, like agent to agent protocol, to the future of AI driven organizations and Fabric? We'll get into that sort of pie in the sky stuff later in the discussion today, but we want to really dig into what we know about agents today and try to explore across what everyone is saying in the industry, see if we can come up with a reasonable definition. And spoiler alert, we have our own definition already, and we're still pretty happy with it at the end of this investigation we've undertaken. So agents, what? We'll talk about the OpenAI versus LangGraph sort of silent war on AI engineering that has become louder. Great article by Latent Space and Swix that we'll talk a little bit about today. And then also we'll get into this idea of a couple different types of agents today and what to look out for tomorrow before we get into the code. So we like to define agent at AI Makerspace simply. It's the same thing as an agentic system. It's a system that can leverage or emulate reasoning or equivalent processes to make dynamic decisions in an application flow. This is important, and it sort of caveats the in an application flow for builders. And with that frame, let's go ahead and bust it out and expand the frame massively here. Let's break this down from first principles. If we go back to original OG AI itself is defined in the textbook that defined AI as the study and design of rational agents. Now, it's interesting because what rational means is it just means uses reason or reasoning. And all reasoning means is that we're thinking through something in sort of a logical way. If then. So AI is really all agents all the way down. So what are agents? Well, agents, we want to think of these as kind of a pattern more than we want to think of agents as a specific thing. One cut we can take on this is the reasoning action pattern, the REACT pattern. This is from a paper in 2022, and this helps us to think as builders about agents. As we ask an agent to answer our question, it's going to have access to things it can do. It can interact and take action. That might be in the form of playing with its environment, or it could be in the form, more specifically, especially with simple LLMs that we have today, the action that it's going to take and plug back into the agent is going to help us provide the answer. And it's generally going to be in the form of calling some sort of tool, calling some sort of function, calling some sort of thing which we can then observe something from, get some sort of result from, and then pump that back into the context window, into the conversation thread that our agent is having. And this idea of using reasoning to help kind of figure out what to do next, and acting to help kind of figure out what to do with what we just did so we can figure out what to do next. This is the sort of core idea. We're looping, we're thinking, we're reasoning. We have agency to do stuff and to look at them, look at the stuff that we do and to see how should this affect what I'm trying to accomplish. An easy way to think about agents today, especially if you're just getting started, is they're just kind of fancy RAG. What do I mean by that? Well, in retrieval augmented generation, we're going to do retrieval, augment the prompt with the stuff that we retrieve, and get a better generation, less hallucinations, and overall just better output, good, correct, more better output. And the idea of like adding agentic tools or reasoning to this, it really allows us to just sort of enhance the new knowledge that we're able to give the LLM. So during this retrieval process, we can actually sort of enhance the search, enhance the stuff we can retrieve. Agents can have access to tools that allow us to get sort of live data and super updated data that maybe a simple RAG application just doesn't necessarily have unless we built it today. And we can augment the prompt in a very similar way. So this idea of like, I'm going to have access to these tools, I'm going to have observations, I'm going to pump that stuff back into the context. I'm kind of doing this in the same way I'm doing RAG. I'm just doing it in a loop. And so this agent is really just an LLM that's putting more stuff in context. And so an agent is, one way of thinking about it is just, it's an LLM that has access to tools. And this is exactly what we see when we start studying some of the frameworks, like LangGraph, for instance. We can kind of just define a problem and kind of set it loose. We talked about coding agents last week, and if you sort of run in headless mode, you're sort of saying like, here's the problem, go. I don't even care what you do, just come back when you're done. And you can also be very specific about tasks. And this is something that some of the other frameworks are maybe a little bit more pointed on, more task oriented, like what's the solution? I already know how I want the solution to look. Here's the task versus here's the problem. You figure out the solution. So more reasoning, more agency in one hand, and we'll sort of come back to this with the idea of workflows versus agents. Now, we can also look at somebody like Chip Wen, who just came out with the AI Engineering textbook, sort of the canonical textbook these days, 2024, December came out. And, an AI agent is meant to accomplish tasks. Okay, let's go deeper. It's the brain that processes the tasks, that plans the sequence of actions to achieve the task and determines whether or not the task has been accomplished. This is that sort of reasoning action pattern that we talked about. So, okay, agents are sort of tools or fancy rag. Great. Let's go deeper into what we can learn from studying the original text. Agent is actually defined in the original text. It's defined as anything. It's literally defined as anything that can be viewed as perceiving its environment through sensors and acting upon that environment through actuators. This is sort of echoed in the later text that we're all familiar with now. An agent is characterized by the environment it operates in and the set of actions it can perform. This is very reminiscent of this React pattern. Want to be able to gather stuff from the environment around. The easiest way to think about this sort of perception, reasoning, and action thing is maybe with some of these computer use or computer using use cases where we're literally actually taking some screenshots. So we actually have more of a environment, so to speak, than just in maybe text world. And then we can sort of reason through those and we can figure out which actions to take. And this idea of computer use or computer using, it turns out this actually wasn't that difficult for people to get to work. This is what Claude and Anthropic told us. And this is what we also saw OpenAI come out with, shortly after. And this is getting sort of easier and easier. We talked about this last week. We talked about coding agents. Now, what is going on here? Well, it's just a single agent with access to many tools. And the tools are just a little bit different than maybe a simple Tavily search. The tools allow us to get these sort of interesting results and take more actions to eventually try to solve the problem. Maybe we can think about this again in sort of a problem context more than a task or solution context. And when we actually call the tool, this idea of like what's going on right here, well, this is the idea of function calling or tool calling. And what it's doing fundamentally is it's kind of combining reasoning and action into a single step. We give the agent some instruction and it's going to figure out which tool to call and why. That's pretty cool. So we can kind of start to get some intuition about this, thinking about kind of tool calling, function calling, fancy rag. We can also kind of take this a little bit to the next level here as we think about cycles and how this thing is cycling through loops. And we think about the complexity that we're sort of building up here. Because as is well known, if we can really set up a system that even with very simple rules is allowed to sort of iterate many, many, many times, we can get extremely complicated and even complex behavior. And this is sort of where AI becomes very kind of futuristic, although the future is getting closer and closer, it seems. you can look back at definitions of agents and think about, this from a book called Complexity, that really sort of studied the idea of complexity with an up and coming research lab in the 20th century, and with some of the best scientists on the planet here in the US. And it was like, well, agents, they can kind of be like neurons of a brain. They could kind of be consumers and corporations in an economy. Each little agent sort of plays its role and interacts with each other agent. And through that interaction of the agents with each other and with the environment, we sort of get this emergent capacity, this sort of complexity that emerges. And this is sort of the scary but promising thing about AI, is when does this happen exactly? And the answer is, well, maybe sooner than we think. And so when we kind of start building applications, we actually don't want to be overly complex. We want to find the simplest solution possible. We want to add complexity when we need complexity. And, so when do we need complexity exactly? Well, this is where we get into the idea of kind of agency and workflows a little bit. Well, if we need to do reasoning auto-magically with an LLM to determine what we should do next, we should think about using an agent. Do you really need the flexibility, or can it be more prescriptive? Can it be more of a classic application where you can kind of code it in kind of more of a hard-coded way? And we can consider kind of the enterprise workflows of the future here as well, where you're sort of sitting in front of a computer and you're getting emails because you're a human, and they're just AIs emailing you. Hey, please validate this. Please validate this. Check on this. Check this data. Hit up this person. Please give me back this data so I can keep moving. And there'll be some sort of centralized brain at the center of the company that's sort of doing this. And that's sort of another layer to think about. There might be chat interfaces that we're engaging with this on, but it's more high level than that. We can go even higher level, as we will. So we've got this idea of the study and design of rational agents. We get this idea that rational is just talking about reasoning or logic. So when we talk about agents, we're really kind of talking about agentic reasoning a little bit here. We're really talking about this pattern of agentic reasoning. And we can see it's kind of fancy RAG, it's kind of tool calling, it's kind of this React pattern. And then we get into this idea of more complex multi-agent systems. And I'd like to offer that our definition kind of extends directly here. A system that can leverage or emulate reasoning to make dynamic decisions in an application flow, where a multi-agent system is going to be something that can leverage reasoning from multiple independent agents to make dynamic decisions in an application flow. You can go to something like the Turing Institute, maybe sort of a modern equivalent of the OG textbook, let's say, to get a definition of a multi-agent system. And it's a system that consists of multiple decision-making agents which interact in a shared environment to achieve common or conflicting goals. And at this point, it's important to ask, as people are doing these days a lot more, when exactly do I need more than one agent? And the answer is kind of like when you need more specialized reasoning machines for one reason or another. OpenAI does a good job of zooming in on this with their new practical guide a little bit, which we'll see in just a moment. This could be separating prompts. This could be separating access to tools. This could be using fine-tuned versions of LLMs for either increased performance on a particular task or increased efficiency to save money and really drive costs down. So if the task is complex, we can sort of imagine developing a multi-agent solution to kind of match that complexity. We can sort of find simplicity in the way we set it up that kind of allows us to get to the other side of the complexity. Imagine the very simple rules between agents and the tools that they have that could then result in something more emergent. Maybe, we sort of get to marry this simplicity and complexity a little bit. And you can kind of imagine, like, with enough agents then, and they have simple rules and tools, we could kind of maybe get this emergence. This is sort of the promise of AI, I think, in the long run. You know, we talked about the agency and code agents last week. And of particular interest are not sort of classic coding or Googling or ChatGPTing, but if we go down to level 7 and 8 here, and we talk about AI software dev teams, we talk about AI organizations, this is kind of that emerging complexity space where we're kind of talking about, where we have multi-agent coding teams that basically replace entire teams of humans right now. We have even you imagine a single person $1 trillion organization or something that might exist in the next 20 years. What does that look like? And what are agents doing behind the scenes? You know, we asked, like, how far away are those agents from the actual work being done? How far away are you as the one person in the $1 trillion company from the work being done, from the scoping, from the planning, from the reasoning, from the coding? And you know, I'd like to sort of bring Wiz up for a moment here, just to sort of discuss this idea of the future fabric here. So if we imagine agents, and I have this whole workforce of agents in the future, like, but they're just little reasoning action patterns with access to tools. Is that the right way to think about this? And then also, if you could, just so we can stay in buzzword compliance, is MCP going to help us with this?
I mean, so I mean, two-parter, right? So yes to the first. I mean, there's all kinds of different ways you can achieve this or think to achieve this. This kind of pattern, right? This kind of you know, next step or next layer or whatever you want to call it. And there are tools that are going to be useful along the way, like MCP, right? So the protocol MCP is useful because it helps us kind of, you know, put our roots down into services. And as those services change, as those services improve, our agent doesn't have to worry about the back end, right? It's going to keep interacting as it always has. And I think this is largely like the pattern we're going to see is that more and more of these standards or protocols are going to be proliferating, right, over the next, you know, how many months. And we're going to find better and better, more and more secure ways to interface between these systems. But yeah, I mean, at the end of the day, when we're thinking about this kind of next step, it is a very busy step that requires access to many different things, and that access must be facilitated between the agent and the service somehow.
Yeah.
You know, MCP or Google standard for now, but I'm certain that will change.
Yeah. Because in order to set these things up properly, we're going to need rules and regulations and protocols and all these things. And I think one of the things, as we'll get into in just a moment here, is like as we see in the orchestration frameworks today, it's like, if you don't have it built into the framework, you just have to code it yourself. It's just more of a custom job. And today, a lot of this sort of futuristic, higher level thing, it's all custom jobs today, but we'll see it start to become more and more standardized to be able to build, you know, teams of coders, to be able to go beyond Devin and Manis, to be able to sort of go and sort of, you know, start to maybe even rent some of the OpenAI agents for $100K a year, you know, and they're working for you as software engineers. So it goes from sort of managed service on AWS to now you actually are renting the agent engineer instead of just the services. You know, something like this, and the rules and regulations aren't there yet, but they're coming into play quickly, it seems.
Yeah, I mean, this is the thing, right? So so when people first started working, right, it was kind of mayhem. We didn't have rules and regulations. You know what I mean? This is like at a new company, right? Something we're very familiar with.
That's right.
You know, there's a lot of people process to work out. There's a lot of, you know, who should have access to what, how should they have access to it, et cetera, right? And this is a struggle companies are used to. The only difference here is that we're talking about an autonomous workforce as opposed to those people. And people have this, this tendency to not explicitly and absolutely follow precisely set heuristics and rules, right?
Yeah.
Whereas the agent workforce, it's code at the end of the day.
Right,
So
yeah.
it's a little bit more on rails, but that's the idea. We have to come up with these protocols for many different layers of this agentic workforce system, right? To facilitate communication, facilitate access, right? Like IAM for agents. There's so many things we have yet to deeply rewrite for this autonomous workforce that I think is going to be a brunt of the maybe not super exciting work.
Yeah.
Okay?
Yeah.
They're really
Standards.
necessary, important work so that we can enjoy these systems outside of the sandbox, which is kind of still where they feel today, right? Like when I interact with an agent, it still feels like it's kind of in a random sandbox. It's just like doing stuff, right? It doesn't feel as part of a well-engineered full system, and that's where we're at.
Yeah. And it's somewhere between, humans that have kind of total agency and code that has no agency. That's where agents live, right? Something like this.
Okay. We're trying to imbue much of the agency that we enjoy into this system as is possible, because agency is a very powerful thing. It's extremely powerful. It's what makes human workers so great, right?
Right. Or not. Yeah. Well, so I think this is a good segue into the way OpenAI and LangGraph today are defining agents. We'll see back in just a moment, Wiz, to continue the discussion. So one of the things that brought this about for us is that, Harrison Chase, the CEO of LangChain, he said, hey, OpenAI recently released a guide on building agents, which contains some misguided takes. Shots fired, let's go. And we thought, wow, that's interesting. For example, this declarative versus non-declarative graphs take here from their guide. Okay, well, rather than focus in on this, let's take a look at their guide. A practical guide to building agents. What do they say in this guide? Well, they say LLMs are becoming increasingly capable of handling complex multi-step tasks. Advances in reasoning, multimodality, and tool use have unlocked a new category of LLM-powered systems known as agents. This guide will help you build your first agent. You'll have everything you need. Just read this guide. And so we return to our question of the day. What is an agent? Well, they have a nice page on this. This is the whole page. We'll check it out in its entirety. While conventional software enables users to streamline and automate workflows, agents are able to perform the same workflows on the user's behalf with a high degree of independence. Thus, and so, agents are systems that independently accomplish tasks on your behalf. Okay, that's OpenAI's definition of agents. A workflow is a sequence of steps that must be executed to meet the user's goals, whether that's resolving a customer support issue, blah, blah. Applications that integrate LLMs, I'll put in little parentheses here, but don't use them to control workflow execution. They don't have that flexibility in the workflow we were talking about earlier. These are not agents. More concretely, an agent possesses two characteristics. One, it leverages an LLM. Two, it has access to various tools. It leverages an LLM to manage workflow execution and make decisions. Access to tools to interact with external systems in the environment, let's say, to gather context. And then note they put always operating within clearly defined guardrails. Ideally, I think that's true. Is it true in general? Well, I think it depends who's building the agent and what they're doing with it. When should you build an agent? This is the next thing that they cover. Well, they're uniquely suited for workflows where traditional deterministic and rule-based approaches fall short. If it starts to fall short, you're like, maybe I need an agent for that sweet, nuanced reasoning capability. And when you're thinking about building an agent, you should make sure that you sort of have these 3 things that are not going to be, well suited for traditional application development. Workflows involving nuanced judgment, difficult to maintain rules, become unwieldy, too many if-thens, and note this one. We'll return to this in just a moment. Or heavy reliance on unstructured data, which is famously, hard to navigate, but LLMs do it very, very well. Much of the rest of their guide is about the OpenAI Agents SDK. We covered that recently a couple of weeks ago. If you want to go into the details and the constructs of the Agents SDK, we'll show you a little bit today during the demo, but I wouldn't worry too much about that. They do say, however, single agent systems can handle many tasks by incrementally adding tools, keeping complexity managed, and simplifying evaluation and maintenance. Can handle many tasks by incrementally adding tools. Each new tool expands its capabilities without prematurely forcing you to orchestrate multiple agents. When should you consider multiple agents? Well, when your agent fails to follow complicated instructions, too many if-thens, or consistently select incorrect tools. Too many tools. So just like we had too many if-thens, do an agent. When we have too many if-thens in the agent, do multi-agent. It makes so much intuitive sense here. So when prompts contain many conditional statements, too complex, too many tools, I got to separate these things. Find the simplicity through the complexity. Now, Harrison, he called him out. He's like, I don't like stuff like that, but at the same time, thinking about these agent frameworks is very complicated. And there's very little precise analysis or thinking being done about agent frameworks. So he wrote a blog. And there were 6 sort of too long don't read points. And I want to go through them step by step with you guys. The first one is the hard part is making sure the LLMs have the appropriate context. We agree at AI Makerspace. This is something we teach as we teach AI engineering. We sort of teach the set of skills and we teach it in context of the particular LLM application stack that most people are using today. The LLM application stack most people are using is based on in-context learning, what we're putting into the context window. And there's sort of 3 stages of putting stuff into context. And retrieval is a big part. And that's where we see agents. We can sort of look at the stack and we can think about the embedding process and building out vector databases with our data, or we can think about actually doing retrieval and augmenting it with APIs and live tools that we can call. This is where agents come in. Next TLDR, agentic systems consist of both workflows and agents. This is one of the key points, the primary points that everybody's talking about and kind of arguing about was sort of I think quote was like a nuanced discussion worth having. So let's have a nuanced discussion worth having on this. Wiz, I want to bring you up for this one. Everybody's talking about this and sort of my sort of 2 cents on this is like, people are like, well, the best framework should have full capacity to do both. And, but there are benefits and trade-offs along each step of this curve. As builders, as the people in our audience trying to build these systems, how should they think about whether or not to care about workflows versus agents? Should they tend towards one or the other? Why? How do you think about this?
Yeah, I mean, I don't think about this too much, honestly. I mean, the framework is just a vehicle, that you can use to get to your destination. As we're going to see, as you've been talking about, many of these frameworks do many of the same things in kind of the same way. I think that at the end of the day, for someone who is building, just kind of picking your favorite one. I know we give this advice all the time, right? The one that you feel fastest with, right? is typically going to be like the best choice. So if you have a preference for one, that's probably the best one for you. If you don't, you're going to see one of them has many green check marks, and like that's a great place to start. Insofar as the impact to like velocity, again, they're all good enough, right, to create all kinds of different systems right now. And so I don't think there's I don't think there's an excellent argument that we could make that would modify or change that.
Yeah. Okay. Yeah. And I think, the key here from reading Harrison's article is this idea of like workflows kind of give you more predictability. Agents kind of give you more agency, and like as you become more agentic, you become have more agency, it becomes less predictable. That's all this is saying. And then the idea of like, well, when should you be super predictable? Probably you should be super predictable when you're just getting started and you don't really know the problem space that well. You don't really know the application that well. And this is his further idea of sort of like ceilings and floors, low floor, high ceiling kind of thing. Like if you're just getting started, start on a low floor, lower code, more predictability, etc. If you really need a high ceiling because you're doing these super advanced things and you need tons of agency and you need like to just orchestrate workflows just enough, then do that. And then I think his point is, LangGraph has the green checks to allow you to do both.
And I mean, it's interesting, right? Because in actuality, like the interface through which you build the agent has very little bearing on the complexity or ultimate functionality of the agent, right? This is kind of where we're at in this world. So
Yeah.
so the idea is like, don't feel like if you need hyper customization and these very like complex workflows that you must use a high code, let's say, example. I mean, low code, especially with the advent of MCP and its the buzz that it's getting, right? You can just point to people's tools and like it'll just work, right?
Use those. Yeah.
That's the idea. It's still right, maybe exactly today, that if you want super complexity, super high agency, high code tools are gonna or frameworks are gonna let you do that in a hyper customizable way. But low code tools are letting us do that. It's just going to take longer. There's going to be more steps. You're going to have to think more. You know what I mean? Like, it's not going to be as direct. You're really going to have to push the tool to its limits. But it's just the case that, again, all of these systems, especially as we develop more standards, especially as we get more locked into to different protocols, right? They're all doing the same thing. And They're all doing it close to the same way. Like, we're going to look at one framework today, which it really shows up in basically every other framework, right? Like, and that's and this is where we're at.
That's right. That's
how we're doing.
Yeah. Agentic really does mean the same thing all the way down. Yeah. Okay, so let's finish these TLDRs here. This was a quick one: declarative versus imperative. This was, I think our take on this was just that kind of like, this was a nice one for him to be able to highlight here, that LangGraph has both declarative and imperative, but it doesn't really have a huge bearing on building these things for people. Anything else to add to that?
I mean, listen, here's the thing. When you look at the difference between declarative and imperative, this is the same conversation we've had for 100 years already in regular software engineering. It's no different. There are people who are passionately on one or the other side of these methodologies. There is there is some sense by which perhaps declarative is quote unquote better because it's more it's more typical of human interactions.
Yeah.
It's more natural languagey, right?
Mm-hmm.
But imperative, again, these aren't people. They're algorithms designed to do precisely what they're told. And so there's this idea of there's this idea that like one might feel more natural, right? And so it's preferred generally, you know, but the other is more typical of how we would think about especially specific, you know, software engineering principles. So
Yes.
At the end of the day, it's the same argument that we've always been having, right? It's like tabs versus spaces level of memeage. But I think there is some interesting psychology that happens with people because these words, you know, send you from a heart rate of like resting 60 to a heart rate of like 130.
That's right. Yeah. So part of it is just knowing the customers here and trying to talk to them about features that might matter to them, which I think is part of this other piece and one of the TLDRs of like all of these kind of have the same bennies and features. And I think like this is sort of the bottom of the chart here that he provided. And, you know, it's like, again, we see sort of many green check marks on LangGraph. Okay, fantastic. There's some comments in here. I encourage people to jump in the sheet and look at those as well. The one piece that I think is worth discussing here is this idea of agent abstractions. And agent abstractions can make it easy to get started, but harder to make sure the LLM has that great context that we need. So, you know, we've taught LangChain for a long time, and we saw the emergence of LangChain into LangGraph. And they both show up on this list. And you can kind of see like one of them is a workflow orchestration framework and one only has agent abstractions. So like what have we learned about this being true or not? You know, should people be thinking about this when they select a tool? I think this is generally the reason why we're saying go with LangGraph, but sometimes you'll need a little bit of LangChain to just chain a couple things together. What's the takeaway here for you, agent abstractions versus orchestration frameworks?
Yeah, I mean, it's exactly right what you said, right? So, period. There you go. The two ideas that matter, right, is that like LangGraph is meant to produce these workflows. It's very good at that. It is meant to design dynamic workflows. It's just really that's what it do, right? LangChain is not designed to do that. It's designed to build. This is going to blow everyone's mind for sure. Chains of Lang, right? Like that's that's all it do. It does it very well, right? And it has like the React agent executor abstraction. And it has blah 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 blah, right? But it's not meant to produce like these agentic workflows because that's just simply not what the tool is good at. Now, like you said, we can leverage things like LangChain, right, inside of LangGraph. This is a very specific example because they're in the same ecosystem and they share the same protocol with LCEL. But at the end of the day, right, LangGraph is going to be more naturally suited to building truly agentic applications versus these kind of like meme agents we had in 2023 2024 right like just look at just React, right? Like that's possible. But if you want to do like the manager hierarchical agent structure, right, and you're reaching for LangChain, you're gonna have it's gonna be tough. You're gonna have a bad time. You're gonna write a lot of extra code than if you had just done import LangGraph, right? So but at the end of the day, I would think about it this way. If you're building an agent, probably you should be looking for something that's meant to build agents, not something that's meant to build, you know, chain applications. Now, listen, 2025, people might think, oh, it's only agents. It's 0% shot. People are still crushing RAG like you wouldn't believe. You know, RAG is dead every day on social media, but in enterprise, it's thriving, right? So the utility of these things is incredibly high, just not for agents.
That's right.
That's not
Okay.
that's not their jam.
Yeah. Okay. All right. Well, I think we've got to sort of wrap some of this up to get it over to you to show us all these frameworks in just a moment here. So we'll go ahead and finish this last TLDR. Check this out. I can't believe they said it. Best thought of as an orchestration framework with a series of agent abstractions built on top. And then I've got a couple more definitions here, Wiz, before we get to you on what is an agent. This is from Harrison's actual blog. We saw from OpenAI's agents are systems that independently accomplish tasks on your behalf. It's just thought leadership and not practical at all. Ooh, love it. Shots fired. Now he goes on to say Anthropic's is better. Agent can be defined in several ways. Ooh, got some flexibility here. Some customers define agents as fully autonomous systems that operate independently over extended periods using various tools to accomplish complex tasks. Ooh, nice little. Others use the term to describe more prescriptive implementations that follow predefined workflows. At Anthropic, we categorize all these variations into agentic systems, meaning workflows that have more predefined code paths, less flexibility, less agency, more predictability, and agents, the ones that maintain control over how they accomplish tasks. And Harrison personally loves this. This is also, I actually kind of love it too. It's pretty robust discussion there. Nearly all of the agentic systems we see in production are a combination of workflows and agents. Love that. And, quick reminder, this is what we like to define agent as. All right, so we were going to talk about types of agents here, and we'll just put a pin in these for later discussions. Agent versus multi-agent. In practice, what matters here? I think the if-thenning all the way up to the top is what matters here. Deep versus shallow agents. This is something we can think about in terms of deep research versus something that just goes out and grabs one specific tool. Are we getting this huge breadth of toolage? What does that look like? And how should we think about those in practice? Are we leveraging reasoning models for our agents or not? How do we kind of get that depth? And then there's this idea of sort of long running agents that you could kind of put in the background of an AI driven organization. The daemon, the demon that we see in like the Docker daemon today is like, what is the AI version of this in the future and how does that manifest? And there's a lot of other ways we can think about chat versus enterprise workflow versus this sort of AI fabric of an organization that leverages MCP, that leverages agent-to-agent protocol, that leverages new protocols we haven't invented yet. We can look even down at similar, smaller scales like we talked about last week, code agents versus function calling. What we want to do now is we want to kind of look at agents in each framework. And I'm going to run through a few definitions, framework by framework, before I pass it off to the whiz here. LangChain says an agent is a system that uses LLMs as reasoning engines to determine which actions to take and the inputs necessary to perform the action. This is often achieved via tool calling. Look at that. Okay. OpenAI Agents SDK says an agent is an LLM configured with instructions and tools. Easy as that. Thanks, OpenAI. Many frameworks actually don't even define agent. They just assume that agent is understood, and they say, here's our agent. AG2 is one such framework. Core building block of AG2 is the conversable agent, a smart interactive agent that uses your configured LLM to process information. With a properly configured LLM, your agents can comms with other agent and human, process information, make decisions, execute tools and functions. When you go to something like CrewAI, what you see that an agent is an autonomous unit that can make decisions, use tools, comms with other stuff, and perform tasks. We see the similar patterns across each of these. You go to something like small agents, you see it's just a program where LLM outputs control the workflow. Now we're back in this. We're using the word workflow to define agent here. I guess that indicates that it's a little bit less agentic, perhaps. Llama Index, a semi-autonomous piece of software powered by an LLM that is given a task and execute a series of steps towards solving that task. You try to go to something like DSPY, it doesn't even define it at all. It just tells you what DSPY is and says, you can do agent loops with this declarative self-improving Python that we've got going on here. And finally, Agentic AI, which we've covered in a recent event. Agents, again, not really defined, but kind of defined. Primary interface, you can think of an agent as a container for system prompt, function tool, structured output type, dependency constraint, LLM model, and model settings. And with that, we're going to head over to the Wiz for a quick whirlwind discussion of the code behind these agents. Let's check it out and see what it looks like under the hood of each of these frameworks that we've covered before on this channel. Wiz, over to you.
Oh, yeah. You best believe that whirlwind's the right way to think of this. Okay, so I'm going to change my screen just a little bit so hopefully you can see it better. Nice. Okay, LangGraph. We're gonna whip through this. Okay, so for apologies in advance. LangGraph. You'll notice we have some kind of graph, right? We add nodes to this graph. We add edges to this graph, and then we compile the graph, right? So we're not saying do this, then this, then this. We're describing what is possible, how we can do things, and then our agent is going to figure its way through our graph. Very cool. Again, you'll notice we can add tools just through nodes. LangGraph, leveraging in the background, everyone's favorite, Pydantic, right? Data models. Okay, that's LangGraph. Agents SDK, it's a little bit different, right? We're still going to, of course, leverage Pydantic because they're all going to leverage Pydantic. That's a big spoiler, right? This time, though, we're going to define each agent individually, and then we're going to allow the agent to figure out what to do by producing some handoffs, right? So instead of producing the full graph, we're going to implicitly define a graph by saying, this agent can go to these agents. What this means is that while we're not going to draw a graph, we're not going to draw the flow chart, we can still absolutely effectively define one. That's the idea. You'll notice, though, that the actual implementation looks quite a bit different, right? Instead of nodes and edges, we're defining many agents and then potential handoffs between those agents. There you go. AG2, a little bit more abstracted, right? AG2 is a higher level framework. When it comes to its most straightforward examples, there is kind of a underlying framework we can leverage. But the idea here is very straightforward. We create some config that tells us what model to use. We create some agent with that config, and then we can run it. Again, much higher level. The power here is a number of interesting or cool, interesting or cool looking, canned recipes, though they do expose the underlying framework. Crew. We all love crew, right? Basically, we're going to define a number of roles, members of our crew, right? We're going to give them some tasks, and then we're going to let her rip. This is it. We don't do more than that in crew. We're very far away from the base level here, right? We are simply saying, here's crews, here's tasks, here's which crews can do which tasks. Run, okay? Crew, classic. Small agents. You best believe that small agents are very straightforward, right? Or else they would be called large agents or something like that. So we have our model, we have our agent. Now, this is what Greg was talking about. It's a code agent. It's not an agent that can code. It's an agent that thinks in code, okay? So instead of tool calling, it's going to write code that could call those tools. It's very conceptually, right? It's a hard line to describe with words, but in practice, it's very, very simple. This is it. Again, we're declaring these things very simply. Llama Index. Llama Index fully embracing the workflow paradigm. Okay, Llama Index is fully in workflow mode. We have steps and we have events. Events trigger steps. Steps do something, and then they trigger the next step. There you go. Llama Index, love it. DSPy. DSPy is very, very powerful. However, you'll notice that it looks super different to the rest of the frameworks. This is because this is a much more optimization focused strategy than the other agents, right? This isn't just stringing stuff together. This is stringing stuff together and then doing some interesting optimization to make it better at that task. At the end of the day, though, we get the same kind of thing. Signatures or prompts, kind of, and then we have agent abstractions. This is not like a workflow style, though, right? This is very much just defining behaviors exactly. Finally, we have Pydantic AI. Pydantic AI is much more similar to the OpenAI model. Of course, Pydantic is going to leverage Pydantic under the hood. We'll see here normal stuff. We declare agents, we declare tools, and then we give agents access to tools. This is the difference, right? Instead of building this, describing this workflow, and then allowing the agent to work through it, we're being much more prescriptive here. We're being much more direct. That is the thing that we're doing. This is the time for 8 different frameworks. The thing I want to clue people into a little bit, though, is that we're all doing the same kind of pattern, right? Except for LangGraph. We have some idea of an agent that we need to build or declare. We have some idea of tools that it can use, and then we run it. There you go. Many agent frameworks, whirlwind style. Boom. Back to Greg. But before we go back to Greg, I'm going to have to ask you to like, comment, subscribe, ring the bell notification. We're here every Wednesday doing this stuff. We love it. Okay, see you in the next one. Let's go to Greg.
Yes, thank you, Wiz. All right, so it's time to wrap up and go to Q&A. As soon as we conclude with a couple of these definitions that we learned. Agents are a pattern. They're kind of that agentic reasoning pattern, the react pattern, the perception, the reasoning, the interaction, or just the action, depending on maybe environment or multi-agent. Maybe another agent is the environment. It's kind of fancy rag. It's kind of tool calling. It's kind of function calling. It's kind of accomplishing tasks and determining if the task is accomplished. It's kind of looking for that simplicity to solve problems that require flexibility. It's looking for how to locate ourselves on that sort of predictability versus agency axis. How much do we need? What tool should we pick up? Low floor, high ceiling. When should we use agents and when should we use multi-agents? Well, every time we run out of if-thens and we need some automated reasoning to help us through, probably pick up another agent. Easy as that. Do you need that flexibility? If not, don't put it in. And that's really all there is to it. I want to bring up Wiz for some questions here. Also, I love some of these comments in the chat here, Wiz. Anthropic's definition versus OpenAI's is analogous to Claude versus GPT in quality. That's a hilarious one. No comment, but yep. And let's go ahead and go with the Slido questions. If Wiz and Greg were to build an agent today, which framework would they pick?
LangGraph.
LangGraph. We are totally unbiased. I mean, although we are kind of biased now because we teach LangGraph more than any other framework in our cohort, but the reason we teach it is because we think it's the best framework. So, and you know, looks like Harrison does as well. A little more biased than us. What's the difference between Llama Index workflows and LangGraph, Wiz? Are both to make agents? Am I missing out on agency if I prefer Llama Index?
That's the right question to ask. The answer is no, not really. They're achieving the same thing. Listen, it's all tieable back to graphs somehow. The Llama index method is just more comfortable for people coming from specific, places in software development. I would say, though, most importantly, that Llama index is approaching it from this event-driven paradigm. Line graph is coming from this graph angle. You're not missing out if you choose Llama index.
Okay. And we know shops that use Llama index over LangGraph. Everybody can produce the same results. It's more of a who can get up and running quicker, who on your team is good with these. Share the slides, of course. How much focus is given on production level agent development in the AI Bootcamp? Production level is an important term to pull apart there. Production grade agents, an extreme amount. I think often people misjudge how important it is to get a thing running in production and then do stuff to it. And that's just something that you have to fundamentally host your thing, get people to use it, see the usage coming in, and then make decisions about that. We'll teach you the frameworks for doing that, but we don't have a product that is up and running all the time for you to be able to see that in. Short answer is a lot. I want to go ahead and just go to one of these questions in the chat. I like this Jeff Davis question here. Convince me, Wiz, that using a framework is better than creating your own bespoke agents when you have varying API and model requirements.
I mean, okay, so it's like the question that I'm going to ask every time is, do you want to build fast, right? Or do you want to build perfect? Okay. 9 out of 10 people are going to say fast over perfect. One thing I will say that I say a lot, I don't want to sound like a broken record or whatever, but also I don't care to sound like a broken record. So here we go. You will at some point want to build something bespoke. Almost certainly, right? Because the idea of these frameworks is that they provide us flexibility, right? They provide us the reason to wibble and wobble and customize very small little tiny hair splitting things, right? But at some point your application is going to be done effectively, right? You're going to have figured it out. You're going to have your agent, and your agent is going to do stuff, right? At that point, yes, we're looking to hardwire / consolidate / build bespoke solutions based on what we have constructed in this quick, flexible period of time. So if you are already finding RAG plus bespoke agents flexible enough for your use case, great. Most use cases are not going to be that way in terms of engineering velocity. It's going to be quicker to use a framework, and then again, once it's crystal clear what you're doing, once it's like I'm locked in, right? Then you're going to find yourself coding away rough edges of the frameworks.
Awesome. And I love the questions coming in, guys, but I'm gonna have to ask you to put them in the YouTube live chat, and we'll get to them asynchronously. That's a wrap on what is an agent. This is the April 2025 edition, Wiz. So this will evolve. This will emerge. We will see agency continue to evolve, and I'm excited for it. 2025.
I can't believe that in the year of agents, our year of agents 2025, okay, we have only now just started scratching a little bit of this deeper surface. The rest of the year, who knows what's in store.
That's right.
So
turns all of AI is agents in the end. So man, it's gonna get wild. Wiz, thank you for your insights today, man. It's time to wrap up. We'll see you back next time on YouTube. And thank you, everybody, for joining us today. If you enjoyed this session, you'll probably really dig our Discord community vibes. We're on a mission to build the world's leading community for people who want to build, ship, and share production LLM, including agent applications. Join us today and start building with folks that are in the Discord and the legends that are building on the regular today. Cohort 7 of the AI Engineering Bootcamp kicks off on June 24th. For the first time ever, we are offering a European-specific time zone, 7 to 9 p.m. CET, taught by international instructors, in addition to the typical one that Wiz and I will teach. Early bird pricing for AIE 7 ends today. So if you'd like to get in for the cheapest possible price, finish your application and the challenge today. We're also excited about new curriculum features, including some that we'll cover next week in the upcoming event we have called the 2025 AI Engineer Challenge. There's some new deployment tools that are a little bit better than Hugging Face. There are some new focus areas in 2025, including vibe coding front ends. We're going to talk more about the agents SDK, more about code agents, more about coding agents, more about computer use agents, all in AIE 7. If you want to go ahead and get ahead of the event next week and start building, shipping, and sharing today for free, go ahead and jump in and take the AIE challenge today before we update it for 2025, so you can get a little bit of that context as you head into the new space. And if you're ready to get after it, 2025, and you want to talk to our team about how we might be able to help, book a meeting, and you can talk to members of AI Makerspace directly about how we can help you get on the path. And thank you so much for joining us today again. What is an agent? This is a tough topic. I hope we did it justice, and we'll continue to try to do it justice in the coming months and years, and long time ahead that we have to look forward to. Lots of cool advancements in AI. And until next time, keep building, shipping, and sharing. We will most certainly do the same. See you all next week on YouTube for the AI Engineering Challenge. Bye, guys.